Lesson 1.2, Measuring Segments. Essential question, how can you determine the length of a segment and use the segment addition postulate? Take time to set up your notes, write the notes title, write down the essential question, and I'll always give you a preview as to what's going to be happening. I leave blank spaces so you can provide the picture, notation, or any extra examples you want. Let's measure the length of ST. Now here's the ruler. I'm going to align the ruler so that the zero's right at the S. So I want the length of segment ST. And I can see that length will be 3.5 centimeters. Each one of these is a centimeter. 1, 2, 3, and then 0.5, half of 1. Now I could have aligned the ruler in a different way. I could have aligned it here like this. Let me go ahead and get a different color. Now you see the S is now aligned with the number 3 and T is aligned with the number 6.5. So to find the length of ST, I would take the coordinate 6.5, subtract the coordinate 3, and I would get the same answer, 3.5 centimeters. So we're going to get the same result regardless of where we put the ruler. And this is what's happening in the ruler postulate. But before we do that, let's talk about what a postulate is. So this is a new vocabulary word. It's a rule that's accepted without proof. And our first ruler postulate says that every point has a coordinate associated with it, just like I did with the number 3 or the number 0. Every point has a real number associated with it. So each one of these has a number associated with it, and it's already been subtracted, and when the two numbers get subtracted, we get what we call a distance. And a distance, the notation for a distance is just the use of two letters. So if I want this distance, I write DE. Notice I don't write a segment above it, and I say distance DE is 23. And I can talk about this distance EF, and that distance is 35. So distances have a different notation. All right, let's do a problem similar to what we did a few minutes ago. I want to align my ruler, and it doesn't matter where. I'm going to align it this way right here. And I can see the coordinate associated with M is the coordinate 2, and the coordinate associated with N looks like it's 6.2. So I'm going to say distance MN is equal to 6.2 minus 2, and the answer is 4.2. That's going to be the distance in centimeters. Now, if I had made a mistake and I had done 2 minus 6.2, I would get a negative number. But if you just take the absolute value, it doesn't really matter what order the numbers are. Distance should always be positive. All right, let's take a look at this next length here. And again, it doesn't matter how I align it. And I'm going to change my color. So at P, the coordinate associated with P is 5. The coordinate associated with Q is 8.5. So we say distance PQ is equal to the absolute value of 8.5 minus 5, which is equal to 3.5. Now, a lot of us can really just count. So we can see 1 centimeter. Oops. Okay, we can see 1 centimeter. Now let me see. This is not. Let me move the thing here. Oops. Okay, so 1 centimeter, 2 centimeters, 3 centimeters, and then 3.5. Some of us can just take a look at the ruler and count like that. Congruent segments. This is our next vocabulary word. Congruent segments are segments that have the same length, so please copy down this picture in your notes. Notice the tick marks. These little tick marks indicate that I'm the same length as you. When we're talking about lengths, under notation, you're going to write this. This says distance AB is equal to distance CD. We use the equal sign when we're talking about numbers. There's going to be a new vocabulary word called congruent. This is the congruent symbol. And congruent symbol means that the set of points are matching with another set of points. So these set of points, if I were to move them, they would match perfectly with these set of points. And this is the way we write it. And we say that segment AB is congruent to segment CD. Notice the word lengths are being used here. Notice segments are being used here. Equals being used here. Congruent being used here. Okay, let's do a problem. J is negative 3, 4. That's J. And K is 2, 4. And this is like being on a number line. And you really could just count. And then you can see that that length is 5. Let's change color. L is 1, 3. And then 1, negative 2 is M. And you can count to figure out that length. And that length is 5. So we can say distance JK is equal to distance LM. And when the distances are equal, the sets of points match perfectly. So these sets of points will match perfectly. We say segment JK is congruent to segment LM. Let's do another problem. A is negative 2, 4. This is our A. B is 3, 4. And we can see that length is 5. Change color. C is 0, 2. D is 0, negative 2. C and D, and you can count and you can see this length is 4. So we can say AB is not equal to distance CD. Now if the lengths are not the same, then we say that the segments are not congruent to each other. There won't be a perfect matching going on. This is a preview question to what we're going to have in just a few minutes. Notice it's like a map. We have the distance from this city to this city. We have a distance from here to here. And the question is asking us to find this distance right here. So I think a lot of us would just take the big distance and subtract the little distance. And so we would say this length is 361 miles. So this is a preview to what we're going to be talking about. And what we're going to be talking about is the segment addition postulate, which says when there are 3 points, 3 collinear points, that the big distance is equal to the sum of the 2 little distances. All right, let's do some examples. I'd like to find DF. That's the big distance, so it'll be equal to the sum of the 2 smaller distances, and the answer will be 58. In this case, we have the big distance, 36, and we want to find, then it must be equal to the 2 small distances, and we're looking for one of the small distances, and so that will be 15. Let's continue doing more problems. We want to find X. We want to find XC, and that's a big distance, XC. So we know it'll be the sum of 2 smaller distances, and the answer will be 73. WY, this length right here, is 30. And the question is, can we find this distance? And the answer is no. And the reason why is point Y, point W, and point C are not collinear. So we don't have this idea of big distance equaling to the sum of the 2 smaller distances. We're going to skip 8. And we go back to the map problem. And in this map problem, we want to find this length right here. So again, we're going to take the big distance, and these points are all collinear, and that'll be x plus 231. And when we subtract, that's going to be 449 miles is equal to x. This is our last slide. And in this lesson, this might be some ideas for you to, questions that you can put on the margin. Like, what is a postulate? And can you give an example of a postulate? This is the end of lesson 1.2.